So the only power we have in this one is to decide what is the center. So if I'm looking at the force on 1 from 2, 2 is my center. That's why I have a little subscript 2 right there. So if Q1 and Q2 are the same sign, so both positive or both negative, then my force is in the positive r hat direction, which means it's away from my center. So Q1 would be going away. So the force at Q1 is away from the center.
Sorry, could you say that one more time?
So K is positive, R squared is positive, R is positive. Q1 and Q2 could be positive or negative. If they're the same sign, the product is positive, which means that my electric force is some positive number, R hat, which means it's away from my center. So if these have the same sign, I get positive R2 hat, which means away from Q2. If they're opposite signs, then this is a negative number. So I get negative something R hat, and negative just means, oh, the other way. So if they're opposite signs, it will be attractive, because it's in the negative R hat direction. You asked me specifically, and I didn't pause after I sort of said it again. Are you good? Or?
Yeah, that makes sense.
Okay.
Yeah.
Other questions right now?
The only thing I'm thinking about is the commutative property, and it seems that whichever direction, whatever the magnitude is, the opposite, Q2 would have the opposite direction, but same magnitude, of whatever the charge is of 1 on 2.
Right.
Right? Okay.
Yep.
So the only reason you put 1 on 2.
This is
Just
on 1
specify-
from 2. The first number is always
on
the
from
receiver.
2, right. But if you had flipped them, it would be the same value, just the sign would change of the answer. Is that right?
The subscript would change. If I flip the 2, this would become R1 hat.
Right. But the value, whatever the value of
Yes.
this would be the same with the opposite charge.
It better be.
Okay.
Or physics as we know it is.
Okay.
Don't destroy this entire line of thinking from one sentence.
Fair.
Thank you. Now, if you want to undermine the foundations of physics because math has made stuff up, go ahead. We're going to come back to that. So right now, I'm just talking about the magnitude of the force. And so I have my value of K just plugging in, so that's 9 times 10 to the 9th in SI units. Charge of the proton, Daniel said it a little bit before now, but 1.6 times 10 to the negative 19. Times the other charge of the other one, 1.6 times 10 to the negative 19. Divided by the distance between them squared. And if someone would be kind enough,
5.76 times 10 to the negative 28.
5.76 times 10 to the negative 28.
Please check it.
Where'd you get 10 to the negative 28? Oh wait, never mind. I see.
But 9 instead of 10.
And units.
No, I stand by it. Could still be wrong.
So I'll go back to my question. And units?
Newtons.
Oh,
Anna, we're gonna get you a new calculator someday.
hey, I like
Can
this
we
calculator.
start like a GoFundMe or something to get Anna a new
I would
calculator?
definitely be down for that. It's failed her too many times.
I don't think it's failed. Like I don't think it's failed you, but I think you just have a lot of trust in it. And
I
like,
do.
Anna deserves a better calculator.
No, I'm very comfortable with it.
Are you?
I am.
Okay.
I appreciate your concern.
Someone written this down. Apparently not. Okay, I'll go off memory.
So I have a quick question. You wrote newtons, but I thought it was Newton meters squared over
Well,
Coulomb squared.
This is Newton meter squared over Coulomb squared.
But the whole thing is
That is
electric.
Coulomb, that's Coulomb, and that's meter squared, because you had meters squared. That cancels out with that. Those two cancel out.
Right, okay.
Also, it's a force.
Right, gotcha.
Now, let's take a look at the gravitational pull between those two protons. Magnitude of that, G 6.67 times 10 to the negative 11. Newton meter squared per kilogram squared. Mass of a proton, I think it's 1.67 times 10 to the negative 27. I'm feeling good about the negative 27. So let's just go with this for now. The mass of proton in kilograms, and divided by the distance between them squared, which is 4. What is the gravitational pull? And I'm gonna set an alarm since that
Can I
clock's not
correct
working.
this? I've got negative 29 instead of.
Yeah, I didn't wanna interrupt, but I wanted to go back to that.
You got 29 as well?
Yeah.
Yes. All right. Does anyone want to say something to Anna?
I've said my
Get a new
piece.
calculator.
I was thinking of what were you thinking, but we're done at 1:20. All right, so we have a 5-minute warning. My alarm goes off. All right, so anyway, gravitational force, what we get? No one, enough confidence to give it a shot?
I was gonna say 9.8, like the constant, but that's not this.
Oh, 2 issues with that. One, 9.8, I assume you meant meters per second squared, which is acceleration. And 2, not a constant.
What is the superscript with both of those tenths? Is that 27
Negative 27.
for both of these black?
Yes. 2 protons, the mass better be the same. Seems like this was 68. Going off of memory.
I got 65.
I had 65.
65? Okay.
Yeah.
Apparently my memory's off.
4.65.
65.
There you go.
I
Alright,
got 67. What did I do wrong?
you had negative 67?
Yes. Hold on.
I got the same answer.
You had the 65?
Yeah.
Oh, that makes me question it.
Now I'm just, hang on.
We're giving you a hard time, Anna.
Either way,
It was,
you know, what's the factor of 100 among friends?
it's negative 11, it's negative
It's-
11, negative 20, oh, that's not a 29, that's a 27.
Yes,
Okay.
alright. Units?
Newtons.
Yes. Okay. Notice the difference between the magnitudes of these two forces. 5.76 times 10 to the negative 29th newtons, and then something that is 36 orders of magnitude smaller. So typically, when you're dealing with electric charge, we ignore the gravitational pull. Unless it's something massive, you know, like a cup, where you can actually start to, would it come into account? But if you're talking about small particles, I really don't care about the gravitational force when dealing with small charges like this. So we've got a plug-in jug there. I'm now gonna, let's do one more plug-in jug. I want the magnitude of the force, of the electric force. On, let's say I've got a 3 nanocoulomb charge here, and a negative 5 nanocoulomb charge there. Now, nano 10 to the negative 9th. I probably should grab my calculator so I know what the answer is. distance between them. Oh, just for something different, let's make it, 3 centimeters between them.
Question, because it's nano coulombs, that affects the formula does it affect the formula at all?
It doesn't affect the formula, it affects what you plug in right here. So for the proton, it was 1.6 times 10 to the negative 19th. Now, for one of the charges, you'll do 3 times 10 to the negative 9th
You just-
coulombs, and then 5 times 10 to the negative 9th coulombs.
Okay, so scrap the like 1.6, like the base charge. Scrap that.
The formula is whatever the charge is times whatever the charge is. In the first example I did, we were dealing with protons which have the base charge.
Okay,
Now we're dealing with something more.
that has the charge. Okay.
Yeah. Just giving you some semblance. So Q1 would be that, the Q2 would be that.
Okay, thank you.
To give some sense of realism here, Van de Graaff generator will probably be on the order of 1,000 times more than this. But as you were dealing with on Wednesday, Rabbit Furgan's PVC pipe, well, actually it was exceeding that, maybe 100 times that.
You would still force on Q1 from Q2.
I'm just looking for the magnitude
Oh,
of the
just the
force.
mag- okay.
I guess formally, the magnitude of the force on Q1, or the magnitude of the force on Q2. The law says that the magnitude of the force will be the same on each. Which I noticed on that multiple choice test, some people seem to forget. You have an answer?
1.5 times 10 to the negative 8.
There is. Oh. Yeah, 9 is, well, I would take off 2 points for that. That's not Newton's, I'll say that. Your denominator. To get Newton's, that needs to be in meters.
Is anyone else getting 4.5 times 10 to the negative 5th?
No.
Does that seem
I
even
did not.
remotely?
I got a negative number, which means, this
Yeah.
should make sense because they're attracted to each other.
Yeah.
That's a positive, that's negative.
We're good?
I got this stuff.
Yeah, thumbs up. Okay, first off, I threw in 3 centimeters as the distance between them. One, because realistically, we could have charges that are 3 centimeters apart and still be able to detect something. But I strongly recommend you put that in meters. With the decimal point over 2 spots, it's 0.03 meters. Squared. Don't forget to,
yeah.
don't forget to square the denominator.
Yeah, I didn't know.
Right,
Forget that.
but now I'm gonna square this decimal.
There we go. Oh, I see a 1.6 right there.
Yeah.
That's, the charges, that 1.6 was because I was dealing with the proton. Now we're dealing with 3 nano
Yeah.
coulomb charge.
Did you guys get negative 1.5, to negative 22?
I did not.
No, that X component is way off.
Okay. Does this look right? Cause are we still using,
That formula.
right, so we're still using Coulomb's constant, right?
Yeah.
Okay.
Yeah, so that's, for the most part, set up right, 0.03, wait.
Right, and I just did that here. Then did I just type this in?
Yeah, you shouldn't have gotten, if you multiply this out, that 10 to the 9th and 10 to the negative 9th cancel out, so
Within
somehow-
The decimal should be over, but.
I think we had
That's
negative
for
nine
also.
coulombs, right? For,
I did.
Coolness, right?
It should be, if you're converting it to coulombs, it's just 3 times 10 to the negative 9. And then negative 5 times 10 to the negative 9.
well, where are you now?
Because obviously it's gonna
Okay.
be really small.
Right. I just.
That is negative 5, right? The charge.
We're gonna talk about that. That is a negative sign right there.
So I've got, that doesn't seem right.
Now you're off by 2 decimal places, another, 0.03.
So. Does that matter?
Something's still off. Let me see what you're typing into your calculator.
So I didn't do 8.9, I just did 9.
Okay, that's fine.
Times 3 That's better.
Yeah.
That's better.
So, yeah, a lesson there is make sure you show your work. Yeah, there we go.
Does it look better?
Yes, that looks much better.
Alright, thank you.
Better when you type it all in at one time. So this size rocks feature.
All right, I am gonna say that. Now, when I was nodding to yes, if you did a straight plug and chug, you got negative 0.00015. Or 1.5 times 10 to the negative 4th. However, if you answered negative 0.00015, I probably have a 10-point problem. Depending upon my mood, I would take off 5 or 6 points.
Because we didn't write units.
All right, so that would account for 3 points there.
You didn't convert it to like the meter. We should have converted it to meters instead of using centimeters.
No, if you'd done it to meters, you would have gotten that number right there.
Scientific notation.
Oh, no, not an issue.
The 0 in front of it? In front of this one?
I'm, put it in, take it out, just make sure I know where the decimal point is.
Oh, because we didn't show our work? Are you
No.
implying that we didn't write stuff work?
No, I'm assuming you're gonna show your work. What was the question I asked?
You asked for the magnitude, didn't you?
Yes.
Oh,
Therefore,
you don't want the negatives.
Because that's what that.
the negative sign is part of the direction. That's the magnitude.
Okay.
Just be careful with the wording. And it's not like I write the test questions thinking, oh, I'm gonna triple up on this one. It's I write the test questions and then later go, oh, wonder why people miss that. So, just be careful. All right, so now, I'm gonna give you a problem that's gonna seem really complicated right now. Or sorry, let me reword that. I'm gonna give you a problem, it's also plug and chug. I'm gonna use some of the same numbers we have up here just to save you some time in using a calculator. I'm gonna have 3 charges. I'm gonna make this 3 nanocoulombs, this one -5 nanocoulombs, and this one 3 nanocoulombs. There's a 3 centimeter separation here, a 3 centimeter separation here. I'm now dealing with a vector. So what I want you to do, I'm gonna call this charge 1, charge 2, and charge 3. What is the electric force on charge 2? Including direction. It is a vector. Now some people will see this and think they have the answer like that. Some people will go through a lot of calculations, come up with the answer, and some people will make a common mistake.
Is this our cliffhanger for today?
Got 9 minutes.
These are charges here. If you think you have it, just somehow give me the nod that I see and. You've already done the complicated part of the math. Because I'm using the same charges and same distances that I had before. Don't forget units, but yes.
Would this be the red?
I understand how you came up with that, but you made the common mistake.